Yes, sir. Tell me. Here. Yeah. Okay. Okay. I'll do that. I'll do that. I'll do the abstract evaluation. Yeah. Yes, yes. I got it. I have just done it. Sure. I just did it. All right. All of you have downloaded the data. So in this data, there are two dependent variables and one set of independent variables. If you look at the independent variables here, they're clearly given in the problem statement. There are two dependent variables, seasonal vaccine, H1N1 vaccine. Whether the person has taken H1N1 vaccine, yes or no. Whether the person has taken seasonal vaccine, yes or no. So you have to build two different models. One model predicting H1N1 vaccine, one model predicting seasonal vaccine using the same set of dependent variables. And if you can go through the problem description and the variable descriptions, you can see here, all the variables are clearly defined. In the problem description, you will see the description of the variables. Train data set, test data set, and labels. Labels means dependent variables. So find missing values or do the info. Also check the info of test. Also check the info of test. So the data set we are using is driven data. So competitions is driven data, flu shot learning, download the data and import it. 3 files will be there, train, test, and labels. So vaccine train.info and vaccine test.info to check missing values. Vaccine train.info and vaccine test.info to check for the missing values. And then concat both the data frames. For cleanup process, we'll concat the data frames. So vaccine test.info. This also has missing values. You can see there are missing values here. So for pre-processing, both train and test. Combined DF is equal to pd.concat vaccine train, comma, vaccine test, comma, axis is equal to 0. Row-wise concatenation. Row-wise concatenation. Combined DF dot is null dot sum dot sort underscore values is equal to false. To find the missing values in the combined data frame. All right. So we have missing values in till now we were using manual method of imputation. Till now we are using manual method of imputation by either imputing with mean of the column or median of that particular column or most frequent of that particular column. There are certain algorithms. Algorithm missing value, algorithm based imputation will consider the impact of independent on missing value and impute algorithm based imputation. There is algorithm based imputations. These algorithms will take into consideration the impact of other variables on the missing value and then impute the missing value. It doesn't happen. In manual, we just take the column mean or column median or column most frequent and then impute it. Here it is not like that. It will study the impact of the independent variables on the missing value. It imputes the missing value. Now, how it does that? If you remember linear regression, one of the output of linear regression is what? Predicted value. You get predicted values, right? So what the algorithms do is they make the missing value column as the dependent variable. They make the dependent, generally they will make the missing value column as the dependent variable and use linear regression. As part of linear regression, you will get the predicted values. Those predicted values will be replaced in place of, same thing happens with logistic regression. We get predicted probability and then we predict classes, right? So all the algorithms will generate predicted values. And these predicted values can be used as replacement for missing values. Now, one of the popular algorithm is multivariate imputation chained equations. Multivariate imputation using chained equations. We call it as MICE algorithm. This is one of the most used algorithm for missing value imputations. It imputes numerical and non-numeric categorical. It imputes both numeric variables and also the non-numeric categorical variable. Very, very powerful algorithm. Very, very good algorithm in terms of missing value imputation. When you are looking at missing value imputations, MICE is a very, very popular algorithm. Now, how does this MICE algorithm works? We have 3 variables: age, income, and gender. We have missing values in age, we have missing values in gender, we also have missing value in 3 variables have missing values. First, it will do mean imputation. First, it will take the column mean and impute it. So the mean imputation of age is 25.5, for income is 12,771. Okay. And then most frequent F will be taken into a random F will be female will be given. Then it will make the age value as missing. It has initially imputed with mean, right? Now it has kept it as missing and it uses linear regression. It uses linear regression to predict age. It will make age as the dependent variable, the other 2 columns as independent variables, and builds a linear regression model. After building linear regression model, you get predicted value. That predicted value will be replaced. So after building linear regression, the predicted value is 35 point. Oh, this is not the complete picture actually. That is why we are not seeing the. So here, see here, it is using linear regression, age tilde income gender. Age is equal to income and gender. It has built a regression model and it replaces the predicted value of age. Then it does it builds a regression model with income as the dependent variable. It replaces the missing value of income with 13,103. And it builds a logistic regression. It builds a logistic regression for gender. Gender is non-numeric, right? It uses logistic regression for gender. Gender is the dependent variable, age and income is there, and predicted is male. Predicted is male. So chained equations will be created. Chained equations will be created. The dependent variable, the missing value, and predictions from the model are used for, it will make the missing variable column as the dependent variable, and it will take the remaining columns as independent variables and builds the linear regression model or a logistic regression model based on the variable type. It uses the predicted values as replacement values for missing values. We are not imputing directly, we are imputing based on the impact of other variables. Based on the impact of other variables on the dependent variable, we are imputing the missing values. So the missing value imputation is done based on, and MICE is a very, very popular algorithm. MICE is very popular and widely used algorithm. Multivariate imputation using chained equations. In our software, we already have this long. Python, they have implemented in experimental phase, it is there. Earlier, we used to run the missing value imputations in R, was having this MICE package from very long. In Python, they are implementing very recently. It's in the experimental phase. In Python, we call it as iterative imputer. Now, you can use any algorithm. You can use any algorithm for imputation. You can use decision tree. You can use random forest, the estimator. Here, you can use any algorithm. You can use decision tree. What is the advantage of decision tree? It works both as regression algorithm, also as classification algorithm. Random forest, gradient boosting, k nearest neighbors. So these algorithms can be used. By default, it is Bayesian ridge regression. I think Bayesian ridge regression is the default. Default is Bayesian ridge. So this is in experimental phase, iterative imputer. Once we have this thing in the next session, next version onwards, I think by next version of sklearn, it will be fully implemented with all the versions. You can use any algorithm. In R also, we have the advantage. We can use decision tree, random forest, gradient boosting, neural networks, anything to impute the missing values. It imputes both numerical as well as non-numeric variables. So all of you understood the working of MICE algorithm, right? Initially, it imputes with mean, median, or most frequent. After that, it will make the missing variable column as a dependent variable, builds the model, and uses the predicted values to impute the missing value. It takes the impact of other variables on the missing value. The impact of other variables on missing value is considered while imputing the missing value, which is considered to be reliable. So that is the advantage of MICE algorithm. Rather than doing a mode imputation or a mean imputation, it studies the impact of other variables on the missing value and then imputes. And in industry, we have to use this when you have very large variables. very large variables, very large missing values are there in many variables. We can't do it manually. We have to use the algorithm based imputation. MICE is the preferred algorithm. There is one more algorithm called probabilistic PCA, but compared to probabilistic PCA, MICE is better. MICE algorithm is better. So this is the performance of MICE algorithm, how it does iteratively. In each iteration, one missing value column will become dependent variable. Predictions will be taken and imputed. All right, can we move forward? From sklearn.experimental.enable iterative imputer or import, from sklearn.experimental import enable iterative imputer, from sklearn.impute iterative imputer, from sklearn.tree decision tree classifier, from sklearn.preprocessing label encoder. Why? Because if you look at your data description, all the variables are categorical in nature. There is no numeric variable in this data. There is no numeric variable in this data. All the variables are categorical. No numeric variable. Not even a single numeric variable is there. You can look at your data. There is no numeric variable. All the variables are categorical. So that is why I have taken it as decision tree classifier. We can also use logistic regression. Yes, we can use logistic regression. You can use random forest also. But compared to logistic, decision tree has a better performance, right? So you want to use, you can use logistic regression. That's not at all a problem. You can use logistic regression, any classifier, k neighbors classifier, if you want to do it based on distance. So it can be anything. Okay. So why I'm using decision tree classifier is it is fast. We have many variables that are missing values. Non-parametric algorithm. No, overfitting will be there. But we are not bothered about overfitting here. We are bothered about filling the missing values. This is a classification problem. Okay. This is a classification problem. Overfitting is when you build the model. After building the model, when you are trying to use that model for prediction, then overfitting problem is the problem to be considered. When you're imputing, it is not going to create any. Second reason why we use decision tree is comparatively it is faster. It is faster than logistic regression also. That is why we use it. Or you can use anything. If you have time, you can use gradient boosting classifier also. Any classifier can be used in this case because all the variables are categorical in. There is no numeric variable in this particular data. Then you have to do two separate imputers. You will anyway split the data. Your num calls and object calls. For object calls, you use classifier. For num calls, you will use regressor. See, when you have both types of data, we will separate them. We will obviously separate, right? Num calls and object calls is separate. We also separate categorical calls from num calls. If there are numeric calls, that means you have to run two imputers. One imputer for classification, one imputer for regression. One on numeric data, one on classification data, and then we'll concat them both back to data. So that is how it works. Because we can't do numeric and categorical simultaneously. Because we have to split the data frames, we'll be splitting them, num calls and object calls. And then we have to run two different imputers. Same imputer. Only thing is the estimator will change. If it is object data, it is classifier. If it is numeric data, it will be regressor. We will work on that also. We will work on that data where we have both numeric and as well as. So all of you have imported these libraries. It doesn't have a library. Open that terminal, type CONDA. After the list of libraries comes, type small y and press enter. All right, all of you got this? Imputation, label encoding must be done. Missing values. The label encoder must run on all other observations except the missing values. The label encoder should encode all other observations except the missing values. Label encoder all other update any libraries. Okay, the restart chain of sorry. Combine df dot head. See here, combine df dot head 10. So we can see the missing values. Let me slightly reduce the window size. So you can see there are nan missing values are there, right? Similarly, other variables also have missing values, which you are not able to see in the top. In middle, there are missing values. So the missing values should not be touched. Rest of all other observations must be dummy encoded. That is the job. So we have to be very careful while doing the missing value imputations. original is equal to combined DF, creating a new data frame called original. Mask is equal to combined DF dot is combined DF is equal to combined DF dot as type dot apply label encoder dot fit underscore transform. Combined DF, wait, that's what I will explain. Combined DF dot where tilde mask comma original. See, this is where we are putting. We are using the word mask. Is null is what? If it is a missing value, we use the word is null to find, right? There we are putting it as mask. We are creating a mask as an option where all the missing values will be aggregated. Now, when we are converting that data frame into label encoder, and we are using the where statement to separate the mask and the original data. It will keep the mask value. So you can see here, combined here, see employment industry, missing values are retained, right? But look at the other things. They are earlier text, na, label encoded. Missing values are kept as, we are masking them. Using the word mask, we separated them. Then we use the where statement to make the mask and original. We'll put the original and we will use the mask as the null. Okay. So the label encoding is done. The missing values are retained as it is, which will be done. So these are the statements. So we are using the mask here where is null will be identified. Then by using the where statement, not equal to mask and original, we are combining them into one data frame. So remember this part. If it is numerical data, we don't need to do this. Only on object categorical data, we have to label encode. For numerical data, we don't need to do this. Label encoding is done only on object and categorical. Never do label encoding on numeric data. Okay. So only on object data. Here, all the observations are categorical or non-numeric. So we are running it on complete data frame. In most of the times, you will have numeric calls and you will also have object calls. Separate them into two different data frames. Label encode object calls for imputer. NP.where is like if statement. It's a if statement. It's like replacement to if statement. A condition. Tilde mask means equal to mask, comma original. That means it will take the combined DF original. We have given original data as combined DF and accept the mask. Rest of the variables will be, or the mask values we have separated initially as null, right? That mask values will be put into the place where in the original data frame. It will replace the values in the original data frame with the mask values. What are those mask values? Missing values. Nans will be, we have separated them and we are using the where, which is an if statement, and we are replacing that mask values in place of the actual missing values. Imputer is equal to, estimator is equal to decision tree classifier, initial strategy, most underscore frequent. Initially, what should we do with the missing value? Initial strategy is most frequent. Max iter is equal to 20. So we have defined the imputer. Separate, we have combined the train and test. Combined DF is equal to combined DF dot drop respondent underscore ID, comma axis is equal to 1. Combined DF underscore im is equal to imputer dot fit underscore transform. Adi nadi part replacement vachindamma coil di Rajesh Prabhakar Vidyanagar. ఇప్పుడు వస్తుందమ్మా, ఇప్పుడు ఆల్రెడీ 1 వీక్ అయిపోయింది. ఆ ఫైల్ లేదు మీ దగ్గర అని వస్తుంది. లేదు ఈ ఇంట్రా ఇది లేదు, ప్యాకేజెస్ లో ఈ ఫైల్ లేదు. గూగుల్ కొలాబ్ వాడండి అయితే, అది వర్షన్ ప్రాబ్లం అది. All of you have run it. All right, all of you have run this. Now once you have run this, the problem is it will convert it into array. You have to convert it back to data frame. Combined df underscore im is equal to pd dot data frame. Combined df underscore im, comma columns is equal to combined df dot. There is no convergence warning here. Early stopping criteria is not reached. See, for some things, early stopping will be there. If it has, we have given 20 iterations. Sometimes it does not need 20 iterations. It can impute within 5 iterations, 4 iterations, like that, it can do that. All the iterations were used for imputation. So in info, you can see all the missing values have been imputed. So now we don't have any missing values. So one of the missing values we had was combined DF employment occupation dot value counts dot plot kind is equal to bar, drop NA is equal to false. So you can see here the missing values are very high. employment occupation. Original data has very large missing values. Now do the for the combined DF impute. Employment occupation dot value counts drop NA is equal to false. Kind is equal to. Now you can see here there are no missing values and it has been spread across all the categories. Same variable before imputation you had very large missing values. The first bar. Now you can see there are no missing values. All of them have been imputed with almost all employment occupations. Now we have imputed the missing values. We also have done the label encoding. Imputation of missing values is also done and label encoding is also done. Now we have to split data back to, so what was the size of the train data? 0 to 26707. Vaccine train underscore DF is equal to combined DF in square bracket dot I location square bracket 0 colon 26,700 or 708. What is the variable size? 26,707, right? That means we have to give 708. Vaccine test underscore DF is equal to combined DF in dot I location square bracket 26,700 53,415. 26,707. 26,708. Here is the problem. If you don't give the yeah, we got it.
Not answering. We join later.
Now we have sorted one problem in this data, which is the missing values. One of the problem in this data is missing values. There is one more problem in this data. Vaccine labels dot seasonal vaccine dot value counts find is equal to bar. The first dependent variable is seasonal vaccine. 0 means no, 1 means yes. So you can see here 14,272 no, 12,435 yes. Almost close to one another. Dependent variable 1 seasonal underscore vaccine balanced data. This is an example of balanced data. That means both the classes are almost equally represented. Dependent variable 2 is H1N1 underscore vaccine. AX is equal to vaccine labels H1 underscore vaccine dot value counts find is equal to for I in AX dot containers AX dot bar underscore label of I. Now you can see here there's a big difference between category 0 and there's a huge difference between category 0 and category 1. This is an example of imbalanced data. So in imbalanced data, prediction of minority class, the minority class predictions will be very, very bad. Majority class, it will predict correctly, but minority class, it will predict very, very. So we'll take a break and then we'll come back. Okay, let's break and then come back. All right. So imbalanced data. Imbalanced data is a big problem in classification. Imbalanced data is a problem in classification. Model performance will be affected. So the imbalanced data, you can see here in H1N1 vaccine, 21,033 is no, 5,674 is yes. Now, what is the problem that causes? In imbalanced data, overall accuracy will be good. You will get overall good accuracy. F1 score, minority class. So when you are looking at imbalanced data, accuracy is not the only measure. Along with accuracy, you must also check recall. Recall is nothing but sensitivity and F1 score. F1 score is again based on precision and recall. 2 into precision into recall divided by precision plus recall. So when you are dealing with imbalanced data, accuracy itself is not the only measure. You have to print the classification report. How will you get classification report? So this is a very, very important issue in classification models. Most of the classification problems are imbalanced data. Most of the classification problems are imbalanced data. See, 95% of the people will pay their credit card bills. Only 5% people will not pay them on time. Imbalanced data, right? 95% of the people will pay their EMI loans, or let us say 90% of the people will pay the EMI loans. 10% will not pay. Again, imbalance. So we will always have imbalance. If you are getting 100 emails, 20 emails will be spam, 80 emails might be There also you have an imbalance. Will all the emails be spam? No, right? Some will be okay, some will be spam. So imbalance is a problem in classification data. So when you have imbalanced data, we have to balance the data. Now let us study what is the effect. Y is equal to vaccine labels dot H1N1 vaccine. X is equal to vaccine train underscore TN. Y is equal to H1N1 vaccine and X is equal to vaccine train DN, our independent variables. From sklearn dot linear underscore model import logistic regression. Logit is equal to logistic regression. Logit model is equal to logit dot fit X comma Y. Okay, iterations are not enough. Max iter is equal to 2000. Logit model dot score X comma Y. 83.06 is equal to logit model dot predict Y comma logit. You got the confusion. From sklearn classification report ROC curve display. Classification report Y comma logit predict. Now you can see here precision for minority class is 0.67, recall is 0.40 and F1 score is 0.50. The threshold was 0.70. All of them should be greater than 0. But we can see here the scores are, but for majority class, they are very good. Majority class is very, very good. But for the minority class, ROC curve display dot from predictions Y comma logic predict, this also will affect. See 0.67 AUC. AUC of 0.67. So this is the problem of imbalance. Imbalanced data will create problems for minority class. The predictions of the minority class will be bad. The overall performance of the model will also be bad. Now, how to deal with imbalanced data? Dealing with imbalanced data, sampling methods. So there are two methods which are generally used: random undersampling, random oversampling. Random oversampling means randomly duplicate examples in the minority class, randomly delete from majority class is undersampling. So this is the concept of undersampling and oversampling. In undersampling, you delete samples from majority class randomly and make them equal to minority class. Whereas in oversampling, you randomly duplicate samples in minority class and make it equal to the majority class. One is random duplication, the other is random deletion. Now, apart from this, we also have some other techniques like minority technique, also called as synthetic minority oversampling technique, synthetic data or artificial data within data range. SMOT is a very, very popular algorithm that is widely used when you are dealing with imbalanced data. It creates synthetic data or artificial data within the range. Pip install, you have to install a library called IMBlearn. Install IMBlearn. Okay, we have installed the library. So this is a library that is in Python for balancing the. So you have this oversampling techniques, SMOT, ADASIN. So we have different types of. So this is a library exclusively developed for balancing the data. You also have combination of oversampling and undersampling. Ensemble of samplers, bagging classifier. So there are many ways in which you can do sampling. Oh, this is sklearn, no, from IMBlearn only. Okay. Documentation, it's coming this place only. Okay. Now we will first do random undersampling. Undersampling, random undersampler. RUS is equal to random undersampler. Random state is equal to 42. We have to fix the random seed so that we all have the same sample. X underscore RUS, comma, Y underscore RUS is equal to fit underscore resample X, comma, Y. So this is our original data. H1N1 vaccine, 21,033 is 0. 5,674 is Y underscore RUS. So undersample. That means we have randomly deleted records from majority class and made it equal to the minority class. So you can see here, Total number of observations is 10,000. 5674 and 5674. Now let us build the model and see what is the impact. From we already have imported logistic regression, right? Model underscore Rus is equal to dot fit x underscore Rus comma y underscore logic model underscore Rus dot score. Accuracy has reduced to 76%. Accuracy has reduced to 76%. Initially it was 83, right? Now it has reduced to 76%. Logic model underscore Rus underscore is equal to logic model underscore Rus dot predict of x underscore Rus. PD dot crosstab y underscore Rus comma logic model Rus. So we have got the confusion matrix. Print the classification report and see how it changed. Classification report y underscore Rus comma logic model Rus predict. Now you can see all the metrics are closer to, once we balance the data, all the metrics are closer to 1, despite the fact that overall accuracy has fallen down by 7%. ROC curve display dot from predictions y underscore Rus comma logic Rus predict 76 improvement rate, right? 0.76. Earlier it was very bad. So 0. And then you can see this was very problematic, right? Now, once you have balanced the data, see here minority class, all are equal, similar to one another. Now let us do oversampling. Implan dot oversampling random oversampler. ROS is equal to random oversampler. Random state is equal to 42. ROS is random oversampler. X underscore ROS comma y underscore ROS is equal to ROS dot fit underscore resample x comma y. Print PD dot data frame of y dot value counts y underscore ROS. See, now both the classes are 21,033, 21,000. So we have duplicated, randomly copy pasted rows in the minority class, and we made it equal to the majority class. We are randomly pasted. Now on this build logistic regression and see how it performs. Built the logistic regression model, accuracy improved or decreased? Same. Yes, we will discuss that. Logic model underscore ROS is equal to dot fit x underscore ROS comma y underscore ROS. 75.75. It was 76. This is 75.75. Logic model underscore ROS underscore predict is equal to logic model underscore ROS dot predict x underscore PD dot crosstab y underscore ROS comma logic model ROS underscore predict. Classification report y underscore ROS comma logic ROS predict. Marginal differences ROS comma same 0.76. The decision to use which strategy should I use is dependent on the data size you have. If you have very small data, undersampling will further reduce the data, right? If the data is already small, say 30,000, like here, we have only 26,000 observations. When I did undersampling, the size came down to 5,674. Whereas when I did oversampling, it went up to 21,033. So the decision to use oversampling or undersampling depends upon the data you have. If you have significant amount of data, large data is there in lakhs, then you can use undersampler. Undersampler is used when you have significant proportion of, oversampling is used when you have limited amount of, okay. So you already have 10 lakh rows, 15 lakh rows, then you have to automatically do undersampling, because building models at such high rows and hundreds of columns is always problem, right? We will generally do undersampling there. Reduce it to 3 lakh rows or 4 lakh rows, then we will also reduce the variables from 150, 120 to smaller number. And then we'll start working with we can't build models with 10 lakh rows, with 100 variables, no. On your laptop, you can't, not even on Google Colab. So what happens? You have to undersample. reduce the sample size. When you are randomly undersampling, you have to make sure all the classes are represented properly. You have other types of sampling also, stratified sampling. Stratified sampling means if there are categorical levels, each categorical level will be taken into consideration while. So you have to make sure the sampling is as much as possible closer to your original. Data scientists do work on sampling. When you are working as a data scientist, sampling is one important challenge you will constantly face. Before doing machine learning, DL or whatever it is, you have to fix the sample, and the sample should be representative of the population. Population means the whole data. It will have a lot of data, but you have to randomly undersample it, and accordingly you have to use it for analysis. Suppose you are trying to analyze in a day, Uber does somewhere around 3 lakh to 4 lakh trips all over India. In a month, 1 crore trips they do. Can we analyze all these 1 crore trips? What we have to do? We have to randomly undersample it to less than 10 lakh rows. But when you are undersampling, you have to make sure that all cities are represented, all time frames, morning trips, evening trips, afternoon trips are represented. All types of trips, surge pricing, non-surge pricing, everything has to be properly represented. Creating a sample is also one of the biggest challenge in data scientists need to understand the sampling theory. Unfortunately, it is not there in our syllabus, but sampling is also one of the important aspect of. Always remember, whenever you are creating a sample, make sure all the categories and classes are, there are different types of sampling methods. Random sampling we are using, stratified sampling is there, judgmental sampling is there, hierarchical sampling is there. So we have to use those sampling methods and then sample the data. Once we sample the data, then we start the pre-processing and all those activities. So sampling is a very, very important task in data science, particularly when you're working with large scale data sets. Like I told you, we also have something called synthetic minority oversampling technique. Minority oversampling, also called as one of the popular methods used in industry to balance the data. One of the most popular method used in industry to balance the data. Smart uses algorithm with Euclidean distance and creates artificial synthetic data. No outliers are created. Generally, when you are sampling, one of the problem is if you don't do sampling properly, outliers will come into picture. And outliers means all your model performance, everything will get. Whereas SMOT does not create outliers. SMOT will do the creation of new data within the, here it is not clearly visible. This is better. Next level. So if you look at here, the circles are majority class samples. The plus are minority class samples. Randomly selected minority sample class is Xi. It randomly select the minority class sample. Then 5 nearest neighbors of Xi. 1, 2, 3, 4, 5 nearest neighbors are selected. And a synthetic sample will be generated using these 5 neighbors. See, the blue one is the synthetic sample. It is within the data range. See, it is the whole thing is working within this particular. No outliers are not created. Outliers are not created within the data range. It will create. See, the blue is the synthetic data, new data point created. Now I'll show you the calculation also. SMOT also uses random for generating. So a random generator will be between 0 and 1. So the calculation is like this. I have 2 independent variables. X1 is age and X2 is income. The observations are 2,400, 2,500, 2,700, 2,900. Oh, X1 is income, sorry. X2 is age, 2,100. X2, these are the observations we have. 34. Choose a randomly selected weight between 0 and 1. 0.60 is the random selected weight. So what it will do is 2,500, 0.60 into 2,400 minus 2,500. A new data point is created, 2,440. Synthetic data point is created, which is 2,000. Similarly, 46 plus 0.60 into 46 minus 34, this would be 53.20 or round it off to 53. This is also a synthetic data point. So this is the methodology or modus it uses to create. So the new synthetic data points are 2440, 2440, comma 53. The new data points will be created like this. Now, the original mode, which I shown you here, works only on numeric data because Euclidean distance can be calculated only on, remember Euclidean distance? Euclidean distance can be calculated only on, now you can see here, SMOT is used only for SMOT NC for both continuous and categorical data. If you have in your data both numeric as well as categorical data, then you have to use SMOT NC. SMOT N. SMOT N is for SMOT N when your independent variables are all categorical in nature, like our data right now, like our data which is now, you can see here, for categorical features. SMOT numerical data, SMOT NC for both numerical as well as categorical data, SMOT N only for categorical data. You also have one more thing, SVM SMOT, ADA SMOT, K-means SMOT. So K-means SMOT is also there, older version. But these days we stick either to SMOT, SMOT NC or SMOT N. Okay, implement SMOT N, just like how we implemented random oversampler and random undersampler. You also have SMOT N. SQL from imbelan.oversampling. This is a oversampling method. From imbelan.oversampling, import SMOT N. It is oversampling technique, creating new data points. Deletion is undersampling. वो नवंबर में रिजेक्ट हो गया. I don't have too many obligations. Yes, I have many obligations. No, it doesn't work. I don't think it was done in November. I was told it will not work for next 1 year. So you can see here oversampling 21,033, 21,033. Instead of randomly copying and pasting, it will create synthetic data. Whereas in oversampling, it just copy paste the rows, copy paste the rows. Here, it doesn't copy paste the rows. It will create new data using the formula. So when you are random oversampling, same data will repeat again and again because it is randomly copy paste rows, right? So the data pattern will not change. It will be similar. Whereas in this case, data pattern will change. I am working, but as a freelance, I don't have salary slips. Trainer. Yeah, it gets in bank only. It comes in the bank only, HDFC Bank. On a particular day, Ematicus learning. See, 81.46. It improved, right? Logit underscore SMOT underscore predict is equal to underscore SMOT dot predict x underscore pd dot crosstab y underscore SMOT comma logit SMOT predict. The classification report y underscore SMOT comma logit SMOT predict. Now you can see all the metrics are closer to one another. SMOT is widely accepted in banking, BFSI, retail, lot of places SMOT is used. One of the robust method to improve the model performance, particularly of the minority class. ROC curve display dot from predictions y underscore SMOT logit SMOT predict AUC of 81. AUC also has. Now, if you are looking at undersampling, we have used synthetic minority oversampling technique, right? There is a undersampling technique also called pairs of observations on the opposite side which are very close. They will be deleted. Observations which are close to one another on the either side. Here we have two types of observations, orange squares and blue dots. These two are very close to one another. These two are very close to one another. These two are close to another. So these sort of things which are close to one another will be identified and will be removed. Deletion is undersampling technique. So let us do this. You have to understand the undersampling technique also. Undersampling, so you will delete the observations which are very close to one another that fall on the opposite side. From sklearn, from imbelan dot undersampling, Tomac is equal to Tomac lengths, random state x underscore Tomac, y underscore is equal to Tomac dot it underscore resample x comma y. Which are sampling strategy we have to use. Sampling strategy, auto we have used majority. So it is not able to remove the very few observations it could remove. 2000 observations, it removed. It didn't remove much. Auto is not minority. So we could remove only 2000 observations. Again, this is imbalance only, right? We will not get a proper output. So in this case, undersampling will not work. Only oversampling, that too smooth is the which you can work upon.